So far during the course, we used to use either the very basic Python variables and so creating functions by ourselves, or using some of the built-in functions like the len, the sum, the max. Today, in this section, we'll learn about the modules and the packages, which will expand the capabilities of our system. So, in practice, real projects are really big, and you cannot actually keep all your code in a single file. And this pushes us to try to break projects to smaller tasks. The idea of breaking a big task to subtasks in programming, we call it modular programming. So modular programming is all about take a big project, break and break and break to small parts. Every one of them is manageable. This has a lot of advantages, like making our life simple, maintainability of the code, your ability to fix and enhance the code, the reusability, like if you did something, others can reuse it, so we don't write it many times. In the Python, the smallest task is named a module. A module is just a single Python file focusing on a specific task. You can think of all of the single files that we were developing through the program actually kind of a module. The package on the other side is one step bigger. The package is a group of modules. So we have a bunch of Python files that are focusing on some subproblem, then we call them a package. There is an interesting thing here in Python, the scoping. Each module has a different namespace. This means that if we have two modules that share the same variable name or function name, there is no collision. So this is a very good thing about Python, and we will understand this point the more we go in this section. Remember the hospital system? We developed all the system in a single file. In practice, we don't do that. Trying to think about the different responsibilities or the different subtasks in the hospital system, we developed an input valid integer function. You can think like we might have a group or a bunch of utility functions. So it might be a good idea to define utilities.python file and put the input valid input function inside this file. Also, we developed the class patient. So what about putting the patient class in a patient.python file? We developed hospital manager. We can also put it in the hospital manager.python file. We developed the front end manager. We can put it also in a front end manager. There is a .python file here. As you see, it seems we can divide our big code to 4 files. Each file is focusing on a very specific thing. In practice, this is how we develop projects in industry. If you have a big team, you might assign for one member the utilities, another one this class, this class, this class, and so on. As you see, this way we can divide tasks, we can review them easily. Let's go back to the modules. In modules, there are 3 things that we typically do in industry. The first thing is to develop your own modules, and we will do that. We already learned how to do the hospital system, but we should be able to split them to different files and use them. The second thing is to use the built-in modules. So far we use the built-in functions, which are in something like built-in.python file like the max and len, but now you can use more built-in modules that are focusing on specific tasks. The third case is to install some external packages. Python is a great community. There are a lot of third library packages. Remember, package is a bunch of modules that you can install and use in your system. So let's see in this video how to use the built-in module. The first module is called math. The math module has a lot of mathematical functions. We don't want the programmers to write from scratch something that compute for them the square root or the factorial or the cosine. If you need that, you can have them implemented for you already. To utilize the built-in modules, you use the word import. Import math. When you write import math, you can use the built-in module math. You can use it using the dot operator. Think of that similar to the class. Remember, when you have an object, use the dot to get what is inside. The dot in a similar way get for us something in the namespace of the math itself. Inside the math, there is a function square root, factorial, there is a constant pi, there is a function like cosine, and so on. So one can write math.square root 16 to get 4. math.factorial 5 to get 120, and so on. You can also use the cosine function, but observe that you don't write something like cosine 90 or cosine 180. You use something like math.pi. So pi for you is you can use it. This is what the function is expecting. You typically don't need that. If you would like to know more about the functionalities available inside the math module, just Google them and you will find out. Another way is just click Control and come to the math, click it. You will get inside and see a lot of available functionalities. So far, this is what we know about the math module and the functionalities. Python provide us with two other flexibilities when it comes to built-in modules in general. The first one is renaming. I can use a module, but I can rename it. Here we wrote import math as xxx. I am importing the math in my namespace here, but I am naming it xxx. Now you can write xxx.python. Note you cannot do math.python, assuming that you didn't write this line of code here. So why do you might need something like that? Let's say you have several modules from different teams. However, there are two of them who have the same name, something like our library, for example. Now you cannot import both of them because it will be confusing. The way that Python solves this problem is using the as keyword. You write something like import our library as library 1, import our library, the second library path, as library 2, and this way you are using both of them. So you typically rename it if there are multiple names. Another popular case, if the library name is very big and you would like to use a very short convention here. It's very common for the guys to import a NumPy as NB, something that's very short, very convenient for use, and I think this is more popular case. So far we learned about importing the library or importing the library and give it another name. There is a third case from the Python. If you would like to make your life easier and print Python directly, factorial directly, which means these variables or these constants are now visible in your current scripts or current module here. To do that, you can do the following. We change the syntax a little bit. You write from math, not import math. From math, import Python, comma factorial, comma whatever you want. What does it say? It says, please bring directly these items for me in my local space so that I can use them directly. I can use them directly. Now you can use by directly and factorial directly. This is good as long as your local file here doesn't have such names, otherwise you will have name collision. The last thing that Python provides us, if you use something like import asterisk. Import asterisk means import everything from here to be visible from my scope. This is a bad thing in big projects because it will typically make name collisions. Name collisions means you have already, let's say you have a variable here in your code that is named factorial. And now this Python here is retrieving from another file factorial. Now one of them will override, the second one will override the first one. So your code only is seeing the second one. So in general, don't follow the line 19 here. Stick to this style, it's much better. Or this one if the names are really unique. So this is 1, 2, 3, 4. These are the 4 ways that we can use to import some module. The last thing, inside the function itself, you can even import a module, and this is sometimes very helpful. Like you don't want the whole code to be affected with the importing of a module, because if the module doesn't exist, for example, the code will fail. So one way to put the importing inside the specific function and use it normally as we did. However, observe that Python doesn't allow you to import asterisk inside a function. It is only allowed at the module level, not at a function level. That's all about built-in modules and modules in general.